In this lecture, we are going to discuss a complete application of test of independence in SPSS. For the test of independence, we need the two qualitative variables, qualitative variable x and y. Both variables should be qualitative with some number of levels. It may have 4 levels, like we may have the first value as x1, x2, and so on. So these are the different values of the variable x, and these are the different values of the variable y. The data is represented in the with the help of a contingency table. So what the assumption is that the two variables are associated or the two variables are independent. The null hypothesis is the two variables under consideration, which are nominal in nature, are independent, and with the alternate hypothesis that these two variables are associated with each other. In this recording, we are going to discuss one complete case. In this case, the data of the US Census Bureau compiled about the population of US. 3 different races and 4 different regions are to be considered. So there are the two nominal variable. One of the variable is region and the other variable is the race. Race having 3 levels: white, black, and other. And the regions are 4: Northeast regions, Midwest region, South region, and West region. So these are the 4 regions. The first qualitative variable is region. The second qualitative variable is race. These are the observed frequencies. 93 participants are in my sample who are from the white race and living in the Northeast region. Similarly, we have a total of 600 participants in this data. Before implementing the complete case in SPSS, the assumptions of chi-square test of independence must be checked. All expected frequencies are 1 or larger than 1. At most, 20% of the expected frequencies may be less than 5. Simple random sample. If the expected frequency is more than 20%, expected frequencies are less than 5, then we have to merge either rows or columns so that the assumptions should be satisfied. The null hypothesis will be the two variables are not associated. The alternate hypothesis, the two variables are associated. Alpha, most probably we use 5% level of significance, and right tail test will be used for this type of analysis. The chi-square test of independence, the formula is observed frequency minus expected frequency whole square divided by expected frequency, and the total will be on the both numerator and denominator. After calculating the observed value of chi-square statistics, we have to check at the degrees of freedom n minus r minus 1 times c minus 1. This is the degrees of freedom for chi-square test of independence. At this degree of freedom, the value of chi-square is known as a critical point. If observed value of chi-square statistics is larger than this critical point, then the null hypothesis will be rejected. So this is the procedure, and we have to implement the procedure not manually. We have to implement the procedure in SPSS. So before going to take the data from here to the SPSS, we should have to code our variables. The northwest is the first level. It is coded as 1. Midwest is coded as 2. And south is coded as 3. And west is coded as 4. So this is the coding scheme that I'm going to implement. And the races are coded as white 1, black 2, and other 3. So these are the codes that I'm going to implement. Firstly, we have to take the data from here to the Microsoft Excel, and from Microsoft Excel we will shift the data to the IBM SPSS. These are the two tables which represent the coding scheme which I used. The coding 1, 2, 3, 4 for the regions. Because we have the 4 regions, both variables are the nominal variable. The races are coded as 1, 2, and 3. Now, how many times we have to create 1 and 1 in Excel? 93 times. Why? Because 93 people are living in the northeast region who are white in race. 14 observations are to be considered in Excel having the number 1 and 2. So this data is to be transformed into the Microsoft Excel in this way. 1 is the region 1 and 1 is the race 1. So 1 and 1 and this 1 and 1 should be copied 93 times. So we have to replicate this data 93 times. Because there are the 93 participants who belongs to the white race and living in the northeast region. There are 14 participants who are living in the northeast and having a race 2, means they are black. So this is to be copied 14 times. It is to be copied because 14 observations are from this. So these are the 14 observations. In this way, you have to calculate, we have to reformat the entire data into the Microsoft Excel. Then I will take the entire data from here and to be pasted in IBM SPSS. This entire data set has 600 observations, and the last cell contains 15 participants from the region number 4, and they are from the other races. So we can see that all the entire data is in the 2 columns of Microsoft Excel. Now we are going to copy these 2 columns from here and we'll paste this into the Microsoft IBM SPSS. These 600 observations are to be taken from Microsoft Excel. Now we have the entire data in SPSS. We have to set the columns, we have to set the values, we have to set the labels. That can be done with the help of variable view. In the variable view, we have 2 variables here. The variable number 1 is region. So I have to change the name of the variable and race. So race and region, these are the 2 variables. Both variable have integer values. So the decimal places are to be set to the 0, and we can set the size of the variable to the 1 digit because these are coded variables and we have digits in that. So these 2 settings are done, and then we have to specify. After setting the type and the width of the variable, we have to set the values. The values, click on the button. In this button, we can have value 1 and value 1 representing northeast. Click add button. When value 2 is representing the Midwest. Click add. value 3 representing south, and value 4 is west. In the same way, we have to set the values for second variable, which is race. The race coding 1 is for white, and 2 for black, and 3 for other. Click OK. Now the rest of the thing is measure. Both of the variable are nominal in nature, so we have to set the measurement scale to the nominal. Now move to the data view. In the data view, if I click on the value label button, this is the value label button. If we click on that, so you can see that the data is appropriately coded. Northeast white, northeast white. Second participant is living in northeast and he belongs to the white race, and so on. So we have the data appropriately arranged in the SPSS. Now we have to perform test of independence for this type of analysis. Click on analyze, then descriptive. In the option we have crosstab. The crosstab is a option which we use for this type of analysis. So analyze, descriptive, and crosstab. This is the option that we have to select. In this dialog box, we have to choose the variable. Regions are in rows and race is in column. We can choose any of the variable in any of the either rows or in column. So there is no exact hard and fast rule to take the region in row or column, because both variable are same in the respect of data type. Now click on the statistics button. In the statistics button, we have an option of chi-square. So click on chi-square and continue. Then we have option of cells. In the option of cell, we have by default observed frequencies are shown. Just click on the expected frequencies too. So now I observed and expected frequencies both will be shown. If you want to see the percentages in rows and column and total, so you can click these options, or you can check these options too. Now click on continue and OK. So these are the outputs. Case processing summary shows that there are 600 valid cases in the data set, and there is no missing number in the both of the variable. It means we have a complete data set. The total 100% observations are given in the data set. So this is a very important thing, because you have to be very clear about the data set and the missing numbers. If you have a missing number in the data, that number should be reflected here in the missing column. The next output is the output of the expected and the observed frequencies. So this is the observed frequency O11. This is the expected frequency E11. E11 can be computed by the formula. E11 is equal to first row total R1 multiply by the first column total C1 divided by the grand total. First column total is 113 multiply by first column total is 491 divided by the grand total is 600. This number is calculated here, and this number is E11. So E11 is the first value of the expected frequency. In the same way, the last expected can be computed as, suppose this is E uh, row number 4, column number 3, E43. E43 can be computed as total of the fourth row. It is 135 multiplied by column third. Total of column number 3, it is 32 divided by 600. This number is computed as 7.2. So 7.2 is the expected count, and this 7.2 is here. This is the 7.2 which is computed by this formula. This is 600, not 60. So we have a value here. This value is 600 because the total count is 600. So in the way the all expected frequencies are computed, we can judge whether the expected frequencies are larger than 1 or not. So all of the expected counts are larger than 1, so there is no need of merging. And all of the expected count are greater than 5, so there is no need of merging the rows or column. Means all the observations in the data set is assumed to be fulfilling the assumptions of chi-square test of independence. The next step is to compute the value of chi-square. The value of chi-square can be computed by chi-square is equal to first observed value. It is 93 minus first expected value. It is 92.5 divided by whole square divided by 92.5. This is first value of the chi-square, which is computed in cell number 1, which is row number 1 and column number 1. In the same way, we have to calculate all the total up to the 12 observations. The last one will be what? The last one will be 15 minus 7.2 whole square divided by 7.2. This is the way for computing the value of the chi-square. And if I am totaling all of these numbers, then their total will be what? Their total will be equal to 26.897. The 26.897 is the value of this total. 26.897. This is the value of chi-square statistics. We call it as observed value of chi-square. The chi-square observed is equal to this number. If the chi-square observed value is larger than the critical value or the critical point, then the null hypothesis is rejected. And the degree of freedom in this case is r minus 1 times c minus 1. So the degree of freedom will be r minus 1 times c minus 1. In this table, we have 4 rows, 4 minus 1, and we have 3 columns. It is 3 minus 1. So 3 multiplied by 2, it is 6. So we have a 6 degrees of freedom. So 6 degrees of freedom, and the value of observed value of chi-square is this. So on the next table, we have Pearson chi-square value. It is computed by SPSS 26.897, and the degrees of freedom is shown here. It is 6. And the probability p-value is 0.000. If the p-value is less than equal to alpha, then reject H naught. Then reject H naught. And in this case, the p-value is 0.000, therefore the null hypothesis is rejected. And the conclusion is the two variables, one is race and other is region. The two variables have association among themselves. The data provides sufficient evidence to conclude that at 5% level of significance that the race and the regions are associated to each other. The indicated zero cell, what this indicated zero cell, it is reference point A. In the reference point A, the zero cell have expected count less than 5. So it is fulfilling the assumptions. The minimum expected count is 6.03 and 20%. We have allowance of 20% to be the expected count should be less than 5, but it is very good. We have all of the expected count which are greater than 5. So in this analysis, the conclusion is the p-value is less than 0.05. Therefore, we reject the null hypothesis and conclude that the region and the races are associated to each other. Thank you very much for watching this video. Allah Hafiz.